Hi everyone. Today we will talk about unlocking AI advancement, the superiority of Lakehouse architectures for hosting enterprise knowledge graph. I'm Waymo from Puppygraph. Before we created Puppygraph, I worked at Google and Telegraph on query language and query engines. Today's agenda will be first, we will talk about the challenge of adopting LLM in enterprise, and then explain why GraphRag can help. We will also show some example with GPT model and IMDb data to prove our point. We will also share how to build a knowledge graph for LLM with our data stack and experience. Finally, we will talk about the advantage of hosting knowledge graph on Lakehouse. First, let's talk about the challenge of adopting LLM in enterprise. The first reason is that it's hard for the ChatGPT to query your private data. The GTP models are not trained on private data, and most enterprise also don't want to share the private data with OpenAI. And the second challenge is that when the query is a data-oriented question, ChatGPT can lead to hallucination when answering such questions. They may provide wrong answers or give a long paragraph, but actually don't really answer the question. We will show the hallucination with a real example. For example, if you ask ChatGPT, what's the nice movie of Tom Hanks? He will talk about, oh, there are a lot of famous movie, and Tom Hanks is a famous actor. But then the last sentence will be, if you have a specific movie in mind that you think maybe he's nice, feel free to ask about it. But when we really ask about the nice movie, like how does Drag Knight rank in Tom Hanks movies? ChatGPT will give the answer that Drag Knight is among Tom Hanks' early movie and talk about what happened in the Drag Knight. It's actually don't answer the question as well. But when we use a GraphRag to answer this question, we can see that the nice movie of Tom Hanks is Drag Knight. We directly get the answer and also a link as a proof. Here's the IMDb reference, Drag Knight. Let's take another look at another question, like which person does Jackie Chan collaborate with most frequently? Then ChatGPT will answer that Jackie Chan is famous for different, is famous for fighting style movie and also have a lot of achievement. But the last sentence is that his Wikipedia page on other filmography resource would offer detailed insight. It's actually not helpful at all and doesn't answer the question. But with GraphRag, we can make it 3 steps: sort, action, and observation. The sort is that we need to find the person Jackie Chan collaborates most frequently. The action is that extract all the person who collaborates with Jackie Chan before and then ranked by the times of collaboration. Then the observation will be the person Jackie Chan collaborates most frequently is James Xie with 181 collaborations. Actually, James Xie is covered the voice of Jackie Chan in animations. And then why GraphRag? First, let's us explain what is a GraphRag. The GraphRag is a RAG based on knowledge graph. GraphRag builds on the concept of RAG by leveraging the knowledge graph already well built by the users or the enterprise. And the GraphRag allows integration of structured data like a knowledge graph. And then LLM can better processing and have a better informed basis for the model response. On the example, we can see that dogs is animals, and the animals is the living things, and the cows is also animals, and herbs, cows eat herbs, and herbs is the plants. Plants is also living things. We can see that the point is the concept and the edge show the relation between the concepts. And it's a lot of famous entrepreneur or scientists already point out that knowledge graph can help and benefits LLM a lot. Jason Huang in Nvidia conference in the keynote show that there are different data sources like structured data, knowledge graph, and the vector database can benefit the LLM and AI in structure. And also Andrew Ng, one of the most famous AI scientists, also have a course in the deep learning.ai talk about the knowledge graph-based RAG. Then let's share how we build our own AI chatbot with private data and LLM. The tech stack include GPT 3.5, MDP dataset, Apache Iceberg as a data storage, and use public graphs to hosting the data in Iceberg as a knowledge graph. We can see there are 3 tables in the AMDB dataset. The first is the title basis. The title basis include movies, animations, and TV shows and others. T-const is the primary key. And the title type may be movies, maybe animations. And the primary title is the name of the movies or animations or TV shows. We can also have some other attributes like start year, end year. And the second table is name basis. Is a person who work in the industry, movie industry, and maybe they are producer, actors, directors, and other roles. Like nconst is the primary key. Prime name is the name of the person, and the primary professions is the whether he or she is the actors or directors or producers. The third table is that title principles. Actually, the connection between title and the names. We can see that T-const is the primary key of title bases, and nconst is the primary key of name bases, which means for a movie which have actors, then title principle will have the T constant as the movie and n constant as actors. Is a relation, a short relation between title and name basis. And we can model these 3 tables as a graph. The blue point is the title, and the right point the person. And the person can cast and be a crew of title. And the person can be actors, actress, and also have attributes like a primary name, birth year, and death year. And the title can have a title type, primary title, start year, and other information. Here, your data is still stored in 3 tables, but logically, you already have a graph schema on top of it. And then you can visualize the data and query the data by public graph. Here, we can see that in the dataset, there are about 22 million vertices and 170 million edges. Then after we have the knowledge graph, we will consider how to answer the question. Like which movie ranks nice in Tom Hanks, over Tom Hanks. We can see that from all the person vertices, find out the point which prime name is Tom Hanks. And then we just find all the movies he acted and ordered by the start year and get the nice. Then we can directly get the name, which is the Dragnet. The query is generated by LLM with some prompt. We can see that it's explainable with an accurate answer. For the second question, who collaborates most with Jackie Chan? We can first get the point type is person and the name is Jackie Chan. And then go along an in edge, then you will get all the titles. And then go along with the out edge, then you will get all the other person. And then we get the prime name, group by the prime name, and get count of all the prime name. Then you will have a list of a person and the counts collaborate with JK chain. We order it by values and get the first, which is James Xie. Finally, let's explain why host knowledge graph on Lakehouse is better than a graph database. There are four main reasons. One is large scale, another is integrated with the existing data pipeline, and also no data duplication. The final one is the total data control. Let's explain one by one. The first is the large scale. In the real world, knowledge graph is usually very huge. Like the Google knowledge graph, when you search on Google search box, and then, for example, Tom Hanks again, then you will see, oh, there are several movies like Forrest Gump, also Drag Knight, and some others. And then you can click another movie, you will get the other actors, producers, directors, and other information. Also, with a very famous knowledge graph is the Wikipedia knowledge graph. You can imagine that it's also it's also a big knowledge graph. The enterprise knowledge graph is large as well, and because the knowledge is increased day by day, so we can easily so the data set can easily up to billions of edges. And the small knowledge graph is limited because the information provided is limited and the value it brings is relatively small. And so the reason why we need to handle a big knowledge graph by Lakehouse is because graph database is hard to handle very large amount of data, and also the cost is very high. No data duplication, since maybe some of haven't realized that the data in Lakehouse already knowledge graph. For example, for e-commerce website, there are tables like customer, product, credit card, purchase history. It's a different tables in Lakehouse, but actually logically is also a graph. Purchase history is actually an edge between customer and the product. When customer buy once of the product, there is an edge between them. It's actually purchase history. You can also have other type of edges like click history. If a customer click one product web page, it's a row in your lakehouse, but also logically the edge between them. They are all connected. Then when the data size is big, no one want to do ETL because it's hard, complex, and expensive. And there must be engineer maintain the ETL to make sure it works well and the data is synced. And also it's hard to and costly to maintain another CDC. The third reason is that integrate with the existing data pipeline. Because if you already set up a lakehouse, the data pipeline run very well. But data is not only used for LLM, it's also for the existing use case. And no one want to bring additional system complexity. And at the same time, if you can model the data in Lakehouse as a graph. You can also run some graph data analysis job like anti-fraud, cybersecurity, and recommendation of e-commerce. Then you can have the insight connection between your data and also have a visualization to make user and the data owner have easy insight on top of your data. In this case, you only have one copy of data, and for your existing data pipeline, you don't need to do additional work, but you have more information and get more value of your data. The final reason is the total data control. Since first, no one wants others, the third party to access their data, not only about the large language model vendor, but also for the data management vendor. Since if you need to have another data stack, you need to reset all the permission and access control. But if we can reuse your current lakehouse to host the knowledge graph, you can just leverage the existing data management instead of bringing additional works. Here's the summary. So we don't need to duplicate data and handle large knowledge graph. And data can be used for the daily data analysis and also LLM and also some new graph data analysis case. You don't need to bring additional data access management to your existing data pipeline. Thank you.